Hello friends, welcome to our channel HTLT Electrical and Electronics Engineering. Here I am going to discuss about busbar system. Some definition related to busbar system. Busbar is the electrical conducting part where all incoming and outgoing circuits meet. From where receiving and sending of electrical powers are made. It may be rigid tubular busbar, flexible AC SR or aluminum alloy busbar for outdoor use. And indoor busbars of aluminum or copper are used in metal panel. The busbars are designed to carry certain normal current continuously. The cross section of conductors is designed on the basis of rated normal current and permissible temperature rise. The value of cross section so obtained is verified for temperature rise under short circuit current. Here it is short time short circuit current. Busbar are supported on post insulator or strain insulator. Rating of busbar: 100 ampere, 200 ampere, 300 ampere, 400 ampere, 500 ampere, 600 ampere, 800 ampere, 1200 ampere, 1600 ampere, 2000 ampere, 2400 ampere, 3000 ampere. Rated voltage: 0.415 kV, 0.6 kV, 3.3 kV, 6.6 kV, 11 kV, 33 kV, 66 kV, 132 kV, 220 kV, 400 kV, 765 kV. The selection of busbar system depends on supply voltage, easy maintenance. Alternative arrangement should be made in the event of any apparatus. Alternative arrangement should be made in the event of an outage of any apparatus and circuit. Easy future expansion available. Economical. Circuit breaker. Simply it breaks the circuit and separates the faulty section at short circuit current. It can make and break a circuit at on load also. Isolator. Simply it isolates a electrical section at offload only. The isolator cannot be operated unless the associated circuit breaker is locked in open position. Bus coupler. In duplicate busbar system, a bus coupling circuit breaker with two associated isolators are provided between two busbars. By closing the bus coupler circuit breaker and change over the circuit isolators, the additional reserved busbar can be energized on load without discontinuity of supply. Okay, next. Types of busbar system. Single busbar system. Single busbar with bus sectionalizer. Duplicate bus with single breaker system. Duplicate bus with double breaker system. Breaker and a half scheme. Main bus and transfer bus scheme. Two main bus and transfer bus scheme. Mesh a ring system. Single busbar system. The single busbar system is simple. There is only one three-phase bus where various incoming and outgoing circuits are connected. For voltages of 415 volt system, another fourth bus is provided as neutral bus. The scheme is not very popular for 33 kV and above in major substation. It is generally used in 11 kV switchyard and very small AC substation or small generating station. It has a lack of operational flexibility. If a bus fault or breaker fault occurs, the total bus bar has to be de-energized for maintenance purpose, and a major outages of circuits occurs. Although the protective relaying is relatively simple, in single busbar system, maintenance without interruption of supply is not possible. Extension of supply without a shutdown is impossible. Okay, next. Here is a picture of single busbar system. Here is incoming circuit, one incoming circuit. Here is the isolator I and series circuit breaker. Here is the isolator I and here is the bus bar. Here is same isolator I, CB isolator, outgoing circuit 1, outgoing circuit 2, outgoing circuit 3, outgoing circuit 4. There are 4 outgoing circuit and this is bus bar. Okay, next. Single bus bar with bus sectionalizer. Because of cheapness and simplicity, single bus bar with bus sectionalizer arrangement is adopted. In this system, the main bus is divided into 2 or more sections with a circuit breaker and isolators in between the adjoining sections. One section can be completely shut down for the purpose of bus maintenance or extension without disturbing the continuity of other section. The number of sections depend upon importance of the station and local switching requirements. Where double feed is required for any single load, it is preferable to have one circuit from each section, so that if a feeder becomes dead during the maintenance of one bus, then the other can continue service from other bus during the maintenance period. Bus sectionalizing should be done through a circuit breaker so that the bus transfer can be done under full load condition. For maintenance of sectionalizing circuit breaker, 2 isolators should be provided with each sectionalizing circuit breaker. If only isolator is used for sectionalizing switch, the opening and closing of the same should be done under no load condition. In case of each section is supplied from different AC source, the bus sectionalizer breaker and the 2 incoming breakers are so interlocked, generally in the form of lock and key arrangement, that only 2 breakers can be closed at a time, or there should be a provision of synchronizing the 2 bus sections. Before closing the circuit breaker, the condition of synchronism shall be satisfied. Okay, next. Here it is the picture of single bus bar with bus sectionalizer. Incoming circuit 1, this is isolator, circuit breaker, isolator. This is sectionalizing circuit breaker. This is incoming circuit 2, isolator, circuit breaker, isolator. I is equal to isolator, CB circuit breaker, and this is the bus section 1 and this is the bus section 2. Two bus sections, bus section, and it is the isolator. This is circuit breaker, isolator, outgoing circuit 1. Here is same for outgoing circuit 2, and here is outgoing circuit 3, same for outgoing circuit 3, and this is outgoing circuit 4. all the same. Isolator, circuit breaker, isolator. Okay, next. Here it is duplicate bus with single breaker system. Duplicate bus system is used mostly for important extra high voltage EHV substation. Duplicate busbar scheme is costlier than single busbar system, but it has higher operational flexibility. In duplicate busbar system, two three-phase buses are provided. One is main bus, another second is reserve bus. The main bus is for normal use and reserve bus is used for maintenance of main bus, cleaning of insulator or fault on main bus. The reserve bus also used for high voltage testing and commissioning of new feeder. During normal service, one bus main is energized and other bus reserve bus and the other bus is kept reserved. There are two types of duplicate bus system. First one, single breaker duplicate bus system. Second, double breaker duplicate bus system. In duplicate bus with single breaker system, each incoming and outgoing feeder circuit is connected with busbar by one circuit breaker and two bus selecting isolators. One isolator for each busbar is provided. There exists a bus coupler in between two buses. In this system, the load is transferred from main to reserve bus after closing the bus coupler in on-load condition, and transfer of loads are done by the changeover of on-load isolators through low impedance path without discontinuity in service. Procedure of changeover. Procedure of changeover. First, close the bus coupler. The two buses are now at same potential. Second, close the isolator on reserve bus. And third, open the isolator on main bus. After transfer of load from main to reserve bus, the bus coupler is opened. The dead main bus are now taken under maintenance. In this system, maintenance of bus is allowed, but maintenance of single breaker is not possible without discontinuity of supply. Okay, next. Here it is the picture of duplicate bus with single breaker system. Here is the single breaker and here is one isolator connected with one bus bar and second isolator connected with second bus bar. Here is the bus coupler. This is CV of circuit breaker of bus coupler. I is the associated isolator of the circuit breaker. This is first closed for transfer of loading to main bus to reserve bus. Say this is the bus bar 2, say this is the main bus. When I transfer the load, first close the circuit breaker, then close the reserve bus, then close the reserve bus isolator. This is, and then open the main bus isolator, and next open the circuit breaker of the bus coupler and associated isolator. Thus the load is transferred here to here. Okay, next. Duplicate bus with double breaker system. In duplicate bus double breaker system, in between two bus bars there are two circuit breakers and four isolators are used per circuit in such a manner that one circuit breaker and two isolators are used for each bus bar. In such schemes, however, no bus coupler is needed. Thus, when one of the circuit breaker is being opened for repairs and usual checks, the load can be shifted onto other circuit breaker easily. In such system, bus maintenance as well as breaker maintenance is possible. But due to high cost of using two circuit breakers per circuit and requirement of land also increased for the utilization of two breakers, this system is not preferred. Okay, next. Here is the picture of duplicate bus with double breaker system. Here is breaker with two associated isolator. Here is the breaker, two associated isolator. This line is goes to busbar 1. This line is goes to busbar 2. Here is the same. Uh, it is incomer 1 and is incomer 2 circuit, and this is the outgoing circuit 2, outgoing circuit 3. Suppose the busbar 2 is running, then and busbar 1 is idle, then just open this breaker and close this breaker. Busbar 2 is running and busbar 1 is idle. Then transfer for load busbar 2 to busbar 1. Open this breaker and close this breaker. Open this breaker and close this breaker. All the circuits are same. This is how transferring the load from busbar 2 to busbar 1 is done. Okay, next. Breaker and a half scheme. This is an improvement of double breaker scheme to effect saving in the number of circuit breakers. Breaker and a half scheme has two bus bars. Three circuit breakers are connected in each bus bar and positioned between two bus bars. For every two circuits, one spare breaker is provided. A feeder circuit is de-energized by opening two breakers. Bus failure does not remove any feeder from the service as the feeding continues from the other bus. Any circuit breaker can be switched off for the purpose of maintenance. The protection and auto reclosing are complicated because the middle breaker should be associated with the breaker on either sides. Breaker and a half scheme is preferred for important large EHB 400 kV and 750 kV substation. Due to cost of equipments, even this scheme has not much popularity. Okay, next. Here is the picture of breaker and a half scheme. Here is the three circuit breakers are connected between two bus bar. Here is the incoming line, come and joint here. Here is the incoming circuit line, come and joint here. Here is the outgoing circuit from this point. Here is also three breakers and associated isolators. Suppose this breaker is removed or off, then the outgoing circuit, this is get supply from this line, from these two breaker. In general, the two bus bar are energized and supply gets from the two bus bar. In this way, outgoing circuit 1, and in this way outgoing circuit 2. If any bus is uh, is problem in any bus or is dead in the bus, then the power also get from this bus, from this line. This is a picture of breaker and a up scheme. Three breakers are positioned in between two bus bar. This is the incoming line and this is the incoming line. To energize the bus bar 2, and this is the incoming line energize the bus bar 1. If these two breakers are off, then the outgoing circuit is not get any power. Circuit 2 is not get any power if this and this breaker is off. Okay, next. Main bus and transfer bus scheme. Main and transfer bus scheme is an alternative scheme of double bus bar scheme. In double bus bar scheme, maintenance of bus bar is possible by transferring load from main bus bar to reserve bus bar, but breaker maintenance is not possible without discontinuity of supply. The main and transfer bus scheme provides facility for carrying out breaker maintenance but does not permit bus maintenance. Whenever there is a requirement of breaker maintenance of any feeder, the feeder circuit is connected to transfer bus by isolator only, and protection is controlled through bus coupling breaker. As the connection to the transfer bus is through isolator only, careful interlocking is necessary with bus coupler breaker. Okay, next. Here is the picture of main bus and transfer bus scheme. Here is the main bus and here is the transfer bus. Here is the bus coupler. Here is the incoming circuit 1. Here is the outgoing circuit 1, and here is the outgoing circuit 2, and here is the outgoing circuit 3. Here is the incoming circuit 2. If it is the main bus, it is energized. If the breaker maintenance is required for circuit breaker is of outgoing circuit 1, then what is done? This isolator is closed and this is the bus coupler. This is circuit. This is also closed. The associated isolator and circuit breaker. Then the power is forward from main bus to transfer bus through the bus coupler and goes to this point and this through this closed isolator and goes to outgoing circuit 1. These breakers are given for controlled the protection of this outgoing circuit 1. Thus the breaker maintenance of this breaker is done. Okay, next. Two main bus and transfer bus scheme. Two main and transfer bus scheme is amalgamation of double bus and transfer bus. There are two main bus are connected with bus coupler, and each incoming and outgoing feeder circuit is connected with main bus bar with one circuit breaker and two bus selecting isolators. One isolator for each bus bar is provided. The load is transferred from main to reserve bus after closing the bus coupler in on-load condition, and transfer of loads are done by changeover the on-load isolators through low impedance path without discontinuity of supply. Procedure of changeover. First, close the bus coupler. The two buses are now at same potential. Second, close isolator of reserve bus. Third, open isolators on main bus. After transferring the load from main to reserve bus, the bus coupler is opened. Thus, the dead main bus is ready for maintenance. There is also one transfer bus which is used for breaker maintenance. When even there is a requirement of breaker maintenance of any feeder, the feeder circuit is connected to transfer bus by isolator only, and protection is controlled through bus coupling breaker between main and transfer bus. As the connection to the transfer bus is through isolator only, careful interlocking is necessary with bus coupler breaker. This scheme extensively used for extra high voltage substation of 400 kV for 400 kV. Okay, next. Two main bus and transfer bus scheme. Here is main 1, main 2, and this is the bus coupler which is closed during the changeover of the isolators. This is the two isolators related to main 1, and this is related to main 2. This is for changeover of isolator is done after closing the bus coupler breaker. After maintenance, then the after changeover, then the bus coupler breaker is opened for maintenance of the reserve bus. And here is the transfer bus. Here is also a bus coupler. This is the isolator for main 1. This is the isolator for main 2. This is done the circuit breaker maintenance or removing a circuit breaker done through the transfer bus circuit breaker. Suppose take the power from main 2 through the circuit breaker. Here it is go, and here it is go to the outgoing circuit in this path. This breaker is off for maintenance. The system is called two main bus and transfer bus scheme. This is extensively used for 400 kV substation. Okay, next. Here it is mesh or ring system. In mesh ring system, the busbar and breaker are in series to form a ring or mesh. The feeder circuits are connected between the breakers. The number of breakers is equal to number of feeder circuits. All circuit breakers are closed during the normal operation. It provides a double feed to each incoming and outgoing feeder circuit. So opening of one breaker under maintenance or otherwise does not affect supply to any feeder circuit. Breaker maintenance is possible. All sections of conductor in the station are covered by the feeder protection and no separate bus protection needed. The ring bus is economical in cost as it requires only one breaker per feeder circuit. Ring bus has good reliability, good flexibility, and is safe to operate. It is cheaper than the double bus or main and auxiliary bus scheme. Ring bus is suitable for important 220 kV and 400 kV substation having up to 5 feeder circuits. So long as the mesh is closed, each feeder circuit has a duplicate feed. So long as the mesh is closed, each feeder circuit has a duplicate feed. If during any circuit breaker taken out for maintenance from the ring and another circuit breaker trips under these circumstances, supply to number of feeder circuits may be lost. As discussed earlier, the mesh scheme is limited up to 5 circuits, so it is unsuitable in developing system. Okay, next. Here is the picture of mesh or ring system. The number of circuit breaker is equal to number of feeder. Here is 4 circuit breaker making a closed ring or mesh. and there is 4 feeder circuit. This is outgoing circuit 2, incoming circuit 2, incoming circuit 1, and outgoing circuit 1. This is isolator, associated isolator for circuit breaker. This is associated isolator for circuit breaker. This is mesh or ring system. Thank you for watching the video. If you think the video is useful to you, then please share it to your friends and subscribe our channel. Okay, thank you. Bye. See you in the next video.